Thank you, everyone. It's a great pleasure to be here in the first edition of Iceberg Summit. My name is Álvaro Santos. I am data solution architect. I work in Syngenta Group. I've been working more than 15 years with data, creating a lot of AI platforms, data lakes, and many things. I'm based on Madrid, Spain, and also I'm from a family of farmers in a nearby province near Madrid. So before going to the talk, I'm going to present where I work. So Syngenta is one of the biggest agricultural companies in the world right now. We basically provide agricultural innovation and technology. And we also have a new brand that is called Cropwise, and is where I work. We provide data services to farmers. So we provide new insights using artificial models and many things just to provide better insights for the farmers. So let's before continuing just the agenda, what I'm going to present to you. But summarize very brief is the evolution of our data strategy in Syngenta. So first we're gonna review our evolution in the strategy. So we move from a data marts strategy to a data products, data mesh one. The second thing, we are gonna see the evolution of our technical architecture, why we have to migrate to a datalakehouse architecture, and also why Apache Iceberg is the foundation of our open data platform. And finally, I will explain you, or will show you some examples of AI integration that we are currently using Iceberg also for that. So before starting, I'm gonna show you one day in a farm dealing with sales folks. So you will have more context about why we do this migration to data product. So imagine you are a farmer and a guy comes to you saying, okay, I bring you something new. This time is really, really good. And the farmer says, hey, hi Carl, what do you have for me today? And he says, well, I have a new drone, the best drone in the market that is equipped with a camera that basically is any bugs won't escape from you again. And the farmers answer, that's awesome, but this time, will I know how much rain is going to come to my fields? And he answered, I don't think so, but you can drive using your phone. Sure, but I had to pass again because, again, what I need is to understand the weather so I can plan better. Basically, the salespeople leaves, and this situation happens a lot in my data products, in my data projects in all the years I've been. So we focus mostly in the tech stack, in how we store the data, than in bringing it to the users what they really want. So I'm gonna present basically the strategy we approached some years ago in my company and why we migrate from data marts to data product. So the traditional approach that we have been doing in the previous years is that a business people can to a BI team and they request some kind of report. This BI team try to create a report, but he figures out that he needs new data. So he must ask to a data team to request the data, to create some kind of ETL. So the data team gets the new data, put in a data mart, and the BI team is able now to create a report. Okay? So this is the typical approach, and it has good things and bad things. So the good thing is that the data mart is very good in storing this data. So it's a subset of the whole data warehouse. It's very specific for the business data. It's also very optimized for query data very fast and also for analytical purpose. And finally, it's very easy to manage because, again, you are storing the data only for your domain, and it's very easy. But there are many drawbacks, and this is where we saw some years ago that it's very difficult, mostly scaling. When you try to scale to a lot of project domains and initiatives. Okay, so the first drawback is that this type of way of working is driven by IT, so it doesn't offer immediate user benefits to your customer. This means that if he wants to query the data directly by themselves and put in an Excel, they have to figure out how to query the data, how the data is, which are the fact tables, the dimension tables. So it's a lot for the user, and sometimes this is not what he wants. Also, it's being developed by global teams. So we have a BI team, we have also a data engineering team, and this creates a lot of issues when you try to scale up, because if your domains wants to create new data initiatives, you have to ask for these teams in order to create these new data initiatives. So you have to wait until they have the capacity. And also, it's not very reactive and iterative. So again, you work with many teams, and you have to figure out how they are working and when they have the capability and many kind of things. And finally, it's mostly focused on analytical. Okay, so some years ago, we figured out that the new config of data product, data mesh is what we want to do. And why was that? So imagine that you are in Netflix, and there you have a lot of TV shows, fields that are very easy to consume. So you just go, see what you want, and you start seeing the film or whatever you want to see. So we want to do the same with data. So the task here is to create data or packs of data that basically are very easy to be consumed by your user. And this is very important. The idea of data product is to bring a lot of value to the business as soon as possible. And also, and it's very important that instead of maintaining the data in a global team, the idea is that every domain that you have in your company, for example, operations, marketing, sales, finance, human resources, they will own their own data, and they are going to create data products based on that. So first of all, it's going to be much faster, and secondly is that they're going to have more insights to the data. So the data they're going to create is much better because they have the understanding and the knowledge of the data. Okay. And defining more a bit what is a data product, and I saw this in this very good website, dataoperatingsystem.com, and they define it as a reliable unit of data or a container of data that enables a direct and seamless impact on business decisions and outcomes at the time of opportunity. This is very it's very theoretical, but I'm gonna present, I think, the 7 characteristics that a data product must have. The first one is discoverable. This means that or imagine that if you cannot find a field in Netflix, you are not gonna see, or anyone is gonna see. So we have to apply the same with data products. So the data products that you create must be in a catalog, and the user must find it as soon as possible or very easily, and they have to consume it in an easy way. The second thing is secure. The data is very likely to be the most valuable asset in your company, so you have to. It must be very secure. It has to comply with many standards. If we talk about banking, is very regulated, so secure is very critical thing. Also addressable. This means that basically the data must be available in a standard way, so it can be used cross-functional domains in different regions, in different multi-cloud environments and technologies. Next thing is trustworthy. This means that the data product, the data you provide, must meet very high quality standards. And in order to get this, you have to create data quality checks, monitorization, alarms, many things that encourage your user or give your user the trust to your data. The next one is natively addressable. So the data, in order to be used, must be system agnostic. So every user who wants to use the data must be, so he must have it easy. So imagine that if it's very complex and they have to use specific libraries, it's going to be very complicated for them. So it's very recommendable to use SQL language or SQL products in order to get access to this data. Also interoperable. Again, the idea of data product is to sell this data product between different domains. So imagine you are in sales, but for marketing, you need the sales. So the data that the data products they create, it must be very similar to yours, or at least technically. So you can reuse these data products in your data products, so you create bigger insights for your business users. And finally, and more important, is valuable on its own. This means, again, with data mesh, we saw that the idea is to store the data in a technical way. So we store the data so it can be query fast, or in a way that the data warehouse don't suffer. In this way, no, we have to change our mind and store the data that the user wants. And this means that you are going to have different tables, and these tables must be consumed in an Excel, for example, or in a notebook. Very easily, go to the table, fetch all the data, and that's it is. That's the idea of a data product. Now that is more or less clear what is a data product, I'm gonna explain a little bit our roadmap for going to data products. So we split the roadmap in 4 different steps. The first one is very important, is exploration. So again, this must be a business centric approach. So first thing you have to do is to identify your business needs, go to business and ask them what they want, what they need. It's very important to address this at first. So also you have to assess your current data landscape. No, this is not reinventing the wheel. This is not creating new data, because this is what we do in technology. No, the idea is that you are going to create data that is valuable. So if the data is there and is good as it is, don't create a data product based on that, or create a new one based on that. So try to see the data you have and what we can do with that, or maybe create a new one. You will see. And also is a feasible study. So you must figure out if this new data product is cost effective, gives value to the business, these kind of things. After that is the definition. So after you know that you want to embrace data products, you have to define what is going to be your data product strategy. This means you have to define the vision, the scope, the priorities you want to achieve, which data products you want to do first, and so on. Also, very important, you have to define the data governance and compliance solution. Again, security and sharing the data is critical for this. So before implementing anything, you have to have very clear what you want, what you want to do and what you want to do to secure it. And also, it's very recommendable to design a blueprint. So every time you start working in a new data product, you start working with the same documents, the same way of working, the same approach. Now, the third step is implementation. So now you want to start creating data products. And the first thing you have to do is to set up the infrastructure. We're going to see later that working with data products means also to evolve your technology, your data stack. So first thing is just set up the new infrastructure. In this case, a new data lakehouse. After that is creating the data product. This means that you have to collaborate with business to draft the data product, create an RFC document where you are going to define the purpose of the data product, which is going to be the use cases he's going to cover, also some examples, Also, the access you want to put in data product, because that data product doesn't mean to be data. It can be reports, it can be features in a feature store, data in a feature store, also machine learning model. It will depend. The idea is to store everything, so to have different kind of access that provides data to your users. Next step is to implement the data product. Just feel free to do it. And finally, in this step is to create, to ensure the data is good, so you can provide different data quality checks. You have plenty of libraries, frameworks to do that. And finally, is adoption. This is also very critical. So imagine you have the best product, and it has happened in many business, in many companies. You have the best product, but your sales department is not good, so they don't sell enough. So even you have a MacBook, but you don't sell it, it's useless for you. So you must create a very good marketing strategy. This means that you have to put your data products in a catalog so everyone can use it, but you must also go to your future users to sell them this data product. So you must create this strategy. It's very important. Also, you have to monitor the performance. You have to ensure that your data products are being used, how they are being used, how much, these kind of things, how it's costing, these kind of things. It's critical to monitor also. And finally, is iterate and scale. So again, I start small, as any other kind of projects, and in the real life, start small and iterate, improve your way of working, and you can scale, creating more and more data products. So now we have cleared the strategy. We realize that data products is the right thing to do. So now we must see that you have to evolve to a new data architecture. In this case, I think, or in Syngenta, we think that a data lakehouse architecture is the right way to do. Why? Because there are new tech challenges when you work with data products. The first thing is complete data integration. So you are going to work with new data. So again, the idea is to create new use cases, new things. So your business is going to gain you, okay, I want this data. This data is in time, but I also the advanced timing, well, many kind of things. So you are going to have more complexity when integrating new data sources. Second thing, and most important, is quick iteration. The idea of data products is that you have to iterate very quick, go to business, see what he wants. Okay, this is what I asked, but this is we must improve. So you have to iterate very quick. And what does it mean? What does this mean technically? That you have to evolve your model. You have to evolve the data you are providing. So the architecture you have must be able to do that. And sometimes with data Mart, it's not possible. Also, the data governance and security. Again, the idea when you sell things, and in this case data, it must be very secure. You're going to sell products to every domain possible, to every user you have in your company, even outside of your company. So you have to provide or create a very strong data governance and security. And also performance at scale. Again, the idea is to sell it. So you have to sell something that is cost efficient. So you have to try to have an architecture that is very powerful, but at the same time is costly effective. And finally, metadata management. Again, the idea of data products is to be shareable. So you have to manage this metadata, the tables, the columns, the different products you have, catalog, many things. And with the legacy data Mart, it's not possible, the idea of data warehouse. So here is what it comes, the data lakehouse architecture. Many of you maybe know this databricks.com diagram. So it explains the story going from data warehouse 30, 40 years ago to what we have now that is called data lakehouse. So at the beginning, we have data warehouse. So they create new databases that instead of working with transactional data, work in an analytical way. So these servers were very expensive, but very powerful for BI and reports. And also we need ATLs. So several years ago, we see that the data is very valuable. So it was created what is called data lakes. So the idea was to store the data as soon as possible, store all the data we have, and then we will see. And this approach means, okay, we store the data and we reuse the data warehouse that was for. So we create some ATLs using the data lake data. And when in some cases, we use the data in datalakehouse, in data lake for exploration, in data science, in machine learning. But the data lake storing the raw data is not used directly by the users. And finally, what we have right now is the data lakehouse architecture. So instead of having different solutions, what we have is a single solution, single data platform that can be used for many use cases. So we reuse some part of the data lake technology, and above that, we provide a new metadata governance layer that is able to provide access to different use cases. So the idea of that data lakehouse architecture, at least in my mind, is to split the architecture in different layers, so you can scale each of them independently. So we have a storage layer where you store the data. In this case, is widely used Amazon S3 or S3 compatible, Amazon S3, cloud storage, Minion, similar things. Then you have a data layer. This is how you are going to store the data. So instead of storing the data in a data warehouse, you are going to store the data in a packet format, in Avro format or C format. And in the last years, including Iceberg, we have what is called table formats. So working with data, working with files is very painful. So some years ago, it was created what is called Iceberg table formats, like Iceberg, that manage working with this data. So you are not going to, again, figure out how you want to delete these files or add new files, append new files. No, Iceberg is going to do that. And also manage many metadata, transactions, and many other things. So now we have the data layer, and now we have the compute. So we also have a compute layer. So it's totally independent. So we can scale as much as needed. So we have different users. They will use different type of workloads. And it won't be attached to the data, like, for example, are in Redshift or in similar data warehouse solutions. So we have samples like Apache Spark, Trino, Snowflake, DatDB, or even now Apache Arrow. And on top of that, we have our governance layer. The idea is that this data must be, the data and the usage must be governed. So we have different solutions. I put some examples like Glue Metastore, Glue Data Catalog, Project Messi, or a data catalog from GSP. And there are other things like for example, data quality and other things that I won't put. But the idea is to, again, to split the architecture in different layers, so it's much easier for you to scale. So what are the benefits of data lakehouse? So first is that it was designed and created to have scalability with cost in mind. Again, the idea is to create something that is costly effective. And with data lakehouse architecture, you will have that. The second thing is not vendor locking. So the idea of using these open formats like Parquet, Iceberg, also frameworks like Trino or Spark, you can run these platforms in every cloud provider. Also, the idea of having different workloads, type of workloads, so streaming, batch processing, and some that very specific to machine learning and so on. Also, the same as with data lakes, it can support different diverse type of data. So you have structured data, semi-structured data, and raw data in general. So we can support everything. And also the idea is to have it has a single repository for many types of applications. So again, the idea is to have something that can be used for many things, not only for BI. It can be used also for APIs, for example, or for machine learning models, or I don't know, whatever is needed. So with Data Lakehouse is split in different layers, so the consumption can scale as you want. So it can be used for many users and for many type of users. Now I'm gonna present you why Apache Iceberg is the foundation of our data platform. And it's very important. So this is our current architecture in Syngenta. So we store the data in S3. We use as data layer Packet files, and on top of that, we use Iceberg. And for consumption, we use Apache Spark and Athena. And on top of that, we use Glue Data Catalog and PyDQ. And as you see, it's very simple, few items, and well, it works quite well. So why we decide to use Apache Spark? So many of you, maybe you have seen this table. So instead of telling you why Iceberg is better than the others, like Apache Hudi or Delta Lake, I'm not a real expert of this. So instead of that, well, you have many people much smarter than me. The creators are here, so feel free to ask them. But instead of telling you why we decided to use and the features, I'm going to present you 3 scenarios where I found, or what we found, that basically, essentially, that Apache Iceberg was a game maker for us. So let's start with the first one, is data model evolution. My challenge was I had to adapt my data model to accommodate what business asked me to do. And this happened a lot. Okay, so you have to modify the model, you have to iterate a lot, very fast, and well, many times the real problem was that I cannot change my model as fast as I want because technical problems, because in some cases I had to duplicate the data because my system cannot accept change in the data column, in the partitioning, and so on. Or maybe it's because it's too slow. So the loading data is so slow. So this is the real problem for me. And why Apache Iceberg solved me? Because it has the schema evolution is very easy, and you can do it without full rewriting the data. And this is very important. And also without downtime. So some features that we found that is very helpful for Apache Iceberg is the zero downtime schema evolution. Also the column type evolution, so you can change from different data formats. And finally, the partition evolution. So you find out that the day is not enough, so you have to go 2 hours. And with Apache Iceberg, you can do that, at least technically. The second scenario, in Europe, we have the GDPR initiative law, and imagine that you have a customer that wants to delete the data because he leaves and he said, okay, I want all my data deleted. And this happened a lot. And the real problem for me is that my current architecture cannot do that. I have worked many times when I was in the data lake stage. I work a lot with Parquet and Hive, and it was very painful. So I had to first figure out which are the files, the directories, where are my data, delete the files manually, then execute many alter tables to delete partition in Hive, so on and so on. And this is because my current architecture is not compatible to delete the data. And Apache Iceberg solved me that, because in the case of GDPR, he provides also many other robust features to support data compliance. For example, as I said before, row-level deletes. This is very important and critical for us. Also, it has the snapshot expiration. So if you want to store the data for 2 years, 5 years, using the snapshot capability is going to be very easy. It's going to be done automatically by Apache Iceberg. And finally, audit logs. So imagine that you have an auditory and you have to provide to them which is the process or the management of the data. You go to the metadata files of Apache Iceberg, and you will see the different tasks you have done to the data: deletes, writes, insert, whatever is there. So it's easy for the auditors. And also, the final scenario is sharing data. So I want to share my data sets to different domains. And what I have right now is that I have to create very complex ATLs. So I duplicate the data. That costs me more. And finally, it creates a lot of inconsistencies. And this is my challenge. The real problem here is that every domain, everyone is using a different data solution and cloud providers. And more important is any of them are compatible. And in the case of Apache Iceberg, being an open source and cloud agnostic solution, I can store easily in a S3 compatible storage, and being a very widely used open source format, many of the data size is going to be compatible. For example, Snowflake is compatible, Athena, also Azure with Databricks. So it's important to have that in mind. And the good features regarding this is you are gonna have vendor lock-in because it's open source. Also the ACID capabilities. So when you share data, it must be consistent. So if you are adding new data, the user must not see that the data is at the middle of the process. So with Apache RFS, we solve that. And finally is the hidden partitioning. And again, this is very painful. So I have working with mini data warehouse. In the case of Redshift, that were in different accounts. So in the case of you have S3 spectrum tables, you have to create partition in both data warehouse. With Redshift, this is not going to happen. And finally, I'm gonna give you some examples where we are using Apache Iceberg to integrate into AI projects. So let's go with them. The first one is feature store. So maybe you know what is a feature store, but it's very, in simple terms, a way of storing data for machine learning initiatives. So it can be reused. Imagine you have the weather data, and it's going to be used for many models. So you store the precipitation, the temperature, and these kind of things in the same place, and these features can be used by many models. So in the case of feature store, we have two main use cases. The first use case is offline, because you are training the model, or online, because you are providing predictions in real time. So in our case, we use Apache Iceberg to store all the data. We are thinking about terabytes of data that can came from real time or in batch. So our core of feature store is Apache Iceberg. is custom made, this feature store. And from the offline store, we move a part of this data to an online store like Postgres or MongoDB. So it can be query very fast when you want online predictions. Next example is recommendations. So we are going to provide recommendation of seats using GPT models. In this case, a user using our apps are going to chat with our ChatGPT compatible bot. And in order to give recommendations, we must provide augmentation. What is called augmentation is essentially some context that you provide to the GPT model in order to give an accurate response. So in order to do this, what you do is essentially store all your knowledge base in different contexts that are going to be used. For example, again, a temperature or the state of the crops or the machinery data, many contexts that has a lot of huge data, and we use Apache Iceberg to store all this relevant context. And from this, we move and we index this data into a vector database. So when we interact with the user, this augmentation is very fast using this vector. And the final example is ground predictions using computer vision. Again, we store the data using Apache Iceberg. And again, it's because it has the capabilities to manage a lot of data and with very good compliance. So in this case, we train the model using geodata that came from imaginary satellites and these kind of things, also from weather providers and these kind of things. We store the data in using Apache Iceberg, and from them we train computer vision models. And real time, using images from drones or tractors, we can execute this computer vision. It provides a prediction, and we give the result to the user. And this is I think the three biggest initiatives we have right now that is using Apache Iceberg, apart from what we call data products. So you have a clear view of what you have been doing with Apache Iceberg. So thank you very much. I hope this can help you when you are in the journey to data products. So feel free to ask any question.
Thank you so much, Alvaro. That was fantastic. I don't see any questions in the chat, but we do have someone, I think, who wants to come online and ask a question. Pauline Tchaikovsky, I'll bring you on and you can ask a question. We've only got 4 minutes though, so I think, is she coming on? Have I done that right? Maybe not. Viniscus, I'll try you if you want to come on and ask a question. Not working. I don't know. Not coming on. It's probably user error. It's got to be something to do with me there.
Well, my contact is there, so feel free to contact me.
Yeah, we've got a question here. So, are you reading Iceberg tables via Snowflake? And if so, what catalog type?
No, so with Snowflake, we are not working. We are an Amazon-based solution. So we don't work with Snowflake. What we are trying to do is to explore new integrations. We are trying to work with Apache Arrow. I think that maybe in this meeting there are people that I think that the integration with Apache Arrow is here and it can be used to read data. So we are trying to work with that. So that's the new thing we are trying to Apache Arrow.
Great.
Snowflake, no.
Thank you. And then finally, what were some of the key challenges you faced during implementation from a technical standpoint?
Good question. So I suppose when you work with this kind of thing, you have to work with many things. As we saw, that a product, that a mesh initiative is becoming very challenging. You have to work with different domains, and having an agreement with the technical aspect is very important. So we try to figure out what was the bureaucratic part was which is the technology that we want to implement is going to be across domains. So in this case, Apache Iceberg. So I think more with technical was more bureaucratic. In the case of technical is to understand how Iceberg works and how to fine-tune Iceberg. And you have to go deep into the documentation and figure out how it works. Also, you have different implementation, Spark and Flink, and it's working with this new table format is not complicated, but takes time to understand how it works.
Thank you. And I think we've got 2 minutes left. So we've got here, what vector database do you use? How do you create the embeddings to move the data from Iceberg to the vector database?
So, in this case, I'm not a real expert. What I know for sure, this was created by MLOps team. So in this case, we use Apache Spark to aggregate the data. This is what I only know. So in this case, I cannot tell you which database. I think is the vector database that is based on an Amazon product, but I cannot tell you. This is out of my scope.
Okay, well, thank you. Well, I think that brings us to time. So sorry we couldn't get to all the questions, but thank you everyone for joining us. And thank you to Alvaro for a great presentation.